Hello and welcome to Lesson 1, Part 1 of Module 1 of Day 1 of Precalculus Online with Miss Beck. Today we're going to be looking at what is a function. Now, if you've looked on the Canvas page, there will have been a link. If you wanted to print out some skeleton notes to complete, you can. We don't normally do that in Precalculus. It's actually much better for you to learn by actually writing stuff out by hand. But when I can, I'm going to post the notes. If you have a printer, you can post them. But you don't need a printer. You don't have to do that. So take a minute. If you've got the notes, find this sentence. If you haven't got the notes, write that sentence in your notebook and choose the words from this word bank to fill it in. Pause your video. Off you go. So what is a function? A function is a relation that maps each input value, often shown by the letter x, onto only one output. It's very important that each x maps onto only is a key word there, only one output value y. Graphs of a function will pass the vertical line test. Some examples in real life would be things like a vending machine and preset buttons on a car radio. Don't suppose anyone really uses these much anymore. Most of us stream stuff on our phone with Spotify or whatever. But let's look at a vending machine. When is a vending machine correctly performing its function? Well, what would be the output we want today? Let's choose hot Cheetos. So the output will be hot Cheetos. What would the input have to be into the machine that you would get hot Cheetos out? It's not actually the money. Some vending machines are free, not often at school, but some vending machines are actually free. The input that you need to put in to get out hot Cheetos would be the code. Say this machine has hot Cheetos at location C3, maybe even at C4 and C5. So if you put in input C3, out come hot Cheetos. Somebody else can come along after you and they can also choose C3. The vending machine is performing its function if they get hot Cheetos too. The vending machine is broken if they press C3 and they end up with animal crackers. They also wouldn't be very happy, probably. So take a second, well, more than a second, look through these examples. Are they functions? If not, why not? You need to write me an example, a reason there, actually write it out. This is a very important part of the question. So pause your video and answer those questions now. So I hope the answers you got were no, yes, yes, and no. And we have to explain why not. So on numbers 1 and number 3, both of these, you've been given sort of a group of ordered pairs. How is an ordered pair related to a function? Well, you've got an x and a y coordinate. An x value is your input, and it's associated with a y value, the output. Remember that on a vending machine, more than one person can put in the same input as long as you always get out the same output. So number 1, our inputs are 1, 2, -4, and 1. They've all got an output associated with them. But when you put in 1, here you get a 2. When you put in 1 here, out comes a 5. So this is not a function because the input x equals 1 maps onto more than one y value. Try and bring your explanation back to the definition. It actually helps you to write out a good sentence. So x equals 1 has more than one y output associated with it, would be another way of writing that. Whereas this one, your inputs are 1, 2, 3, 4, and 1. So the one input of 1 is repeating, but every time you put in a 1, out comes a 2. Put in a 1, out comes a 2. Let's have a look at number 2 and see why that one is a function. You don't need to write anything about this because it is. Remember that a function maps one set of inputs. Each input is mapped onto one output. So here are arrows showing the mapping. So these must be our inputs and those must be our outputs. Our inputs are 1, 2, 3, and 4. 1 maps onto 6, 2 maps onto 8, 3 maps onto 8, and 4 maps onto 9. Now, 2 of our inputs, inputs 2 and 3, both map onto the output 8. That's okay. This is just telling us it's not a one-to-one function. But each input only goes to one output. That's the important part. And on number 4, why is it that the input value x is the height of a student in inches and the output value y is the number of books that the student owns? This is not a function because your height and how many books you own are just not even related. Okay, moving on. So your vertical line test. Your vertical line test, you just run a vertical line over your functions and decide if it passes. So it passes if no 2 points on the graph of a function can lie on the same vertical line. Why is that checking? How is that checking the definition? Well, this vertical line is checking an individual x value. When I have it here, it's checking the x value -8. Where this line crosses the graph is there, which looks like it might be at y = 8. So the input -8 has the output y is 8. Here, my input of 4, x is 4, has got the y output of -4. Wherever I put this vertical line, it's only crossing that curve of the graph once. Now, if I go over to this graph, as soon as I start scanning across, it's failed. When x is -8, I'm getting this output value. It's not quite at, that would be 2468. It's a value a little bit less than y is 6. And it's crossing down here as well, which would be a number about like negative, that's -6. This is crossing slightly above that. That would be at like, I don't know, -5.5. So all of these x values in this part of the graph are all failing. They're all crossing the graph in more than one place. At the vertex of that parabola here, when x is 6, y is 0, I've only got one y value there. And for x values bigger than x is 6, I don't get a y value out at all. Now this is fine. It's okay to not cross the graph at all. The only thing that it's not okay to do is cross the graph more than once. So this one is not a function. There's my answer in there. Not a function, because for x values less than 6, there is any x value less than 6, not equal to 6. When x was equal to 6, only got one value. But for x values less than 6, there's more than one y value associated with those x values. And moving on, this is going to be the last slide of this video. Are these functions? Now we're going to do some algebra. We've been given an equation and we're going to have to do some algebraic manipulation to work out whether these are functions. So remember the definition, each x must only give me one y. So what I'm going to do is I'm going to solve each equation for y and then think, if I put in one x value, would I get more than two answers for y? So solving this first one, subtract x squared from both sides and I'd end up with just the y. I'm going to write that as -x squared plus 1. If you've written 1 minus x squared, that's the same thing. I just tend to always put the highest power of x first. So put in some x values. They'd get squared. You'd get a positive number that then has to be multiplied by a negative. So you're going to get a negative number plus 1. You're only going to get one y value out for each x value. That's fine. This one is a function. Now, you have a go at number 5. Pause your video. Come back if you need me to go over it in more detail with you. So on this one, I have to solve for y. So first of all, I'm going to move this x to the side. So I get y squared equals x plus 1. I'm going to get rid of y squared and just make it y by taking the square roots of both sides. So at this point, the square root of y squared is just y. I've got y equals the square root of x plus 1. That's looking fine. Imagine putting in an x value. I'm going to make this nice and easy. Put in x is 3. 3 plus 1 is 4. We all know the square root of 4. It is, it isn't just 2, is it? Remember that when you're taking a square root, you're going to get a positive and a negative root. If you're taking any root to an even power, square roots, fourth roots, sixth roots, you're always going to get 2 roots. So this is going to fail. I put in one x value and out comes y will be the positive and the negative root of whatever this turns out to be. If I put in 3 here, my y would be plus or minus 2. So that would do as an answer. You could say this is not a function because there will be more than one y value for some x values. Or if you want to be really precise, let's work out what is the smallest x value I can put in and get out an answer at all. And then any x value is greater than that will give me 2 roots. Put in x is 0. 0 plus 1 is 1. I can still take the square root of that. Square root of 1 is 1. So if I put in x is 1, y would be plus or minus 1. if I put in x as 0, sorry, I got lost there. If I put in x is -1 plus 1 is 0. So my y would equal plus or minus the square root of 0, which would be plus or minus 0. Well, they're the same thing. I'm only getting one output there. So putting in x as -1 is not going to be a problem, but putting in anything bigger than that will be a problem. And if I put in something smaller than x is -1, like if I put in x is -2, I'd be trying to take the square root of a negative number. I wouldn't even get a real value answer at all. So on this one, this is not a function because there will be 2 roots for any value of x that's greater than -1. Hope that made sense. On to video 2.